electro discharge machining process, EDM, the metal removal mechanism. When the breakdown of dielectric medium takes place, a cold emission of electrons takes place from the tool phase, and this causes the ionization of the work. So, what is saying here? When the breakdown of a dielectric medium takes place, a cold emission of electrons takes place. What will happen? When the dielectric medium takes place, a cold emission of electrons takes place from the tool phase, and this causes the ionization of the work gap. So, the metal removal mechanism in the EDM process. The rapid flow of electrons and the ions takes place. What will happen here? The rapid, that means a faster rate of the flow of electrons takes place, and the ions also takes place. That means the rapid flow of electrons and the ion, both will takes place. The resistance of the dielectric reduces. The resistance of the dielectric reduces. Then the spark is discharged in the gap between the tool and the workpiece. The spark will get discharged, that is the gap between the tool and the workpiece. The entire process occurs in a few microseconds at a temperature more than 10,000 degrees Celsius. See here, the temperature process the entire process occurs in a few microseconds, that is at a very shorter time at a temperature more than 10,000 degrees Celsius. So, the spark causes instantaneous melting and evaporation of metal. So, due to the high temperature, that is up to 10,000 degrees Celsius, what will happen? The spark causes instantaneous melting and the evaporation of a metal. By using dielectric medium in a place of air, gas, the erosion of the metal takes place. So, what we will do? By using the dielectric medium, which may be the fluid, which is placed in the air or the gas, the erosion, that means the removal of excess metal will take place. So, the dielectric liquid is circulated to carry away the particles of removed work metals and the tool metals. The electrical liquid which is circulated to carry away the particles of the removed work metal and to the tool metals. So, the volume of the metal removed per discharge is given by V equal to KTI to the power of 3 by 2. So, this is the formula where we will measure the volume. V is equal to crater volume in mm cube, T equal to discharge period in microsecond, I equal to current in amperes, and the K equal to constant. By this we will measure the volume of the metal removed per discharge. So, for the metal with melting points above 600 degrees, the constant K equal to 6.6 into 10 to the power of minus 3 by sigma, where sigma is equal to ultimate tensile strength in Newton per mm square. So, EDM circuit elements. So, I am making a zoom. So, from my right side, I will tell the parts: rack, tool holder, tool, below that the drilled passage, dielectric fluid, DC supply, insulator, table, tank, and from the left side of me, gearbox, servometer, DC supply, pump, and the workpiece along with the positive and negative terminal. These are the main basic elements. Dielectric tank with the work table, dielectric fluid, dielectric circulating system, the tool, power supply unit, servo controller, and the control panel. These are the various elements in the EDM. So, this is a solid figure for the EDM equipment. This is the solid figure for the electro discharge machining equipment. So, first we will go for the work table. The work table is made to hold the workpiece, as we know, and also we have seen in our earlier classes. The work table is made to hold the work table, which is made up of an insulating material placed in a dielectric. So, that is made up of an insulating material which is placed in a dielectric fluid. So, the work material is submerged in a liquid dielectric tank. The work matter is submerged, that means placed under the liquid dielectric tank. The tank is provided with the outlet for recirculation of dielectric liquid. So, here you will see the tank which is having both inlet and outlet. So, those are provided for the outlet of circulation of the dielectric fluid. EDM elements, dielectric fluid. A hydrocarbon like kerosene, paraffin, transformer oil, polar organic compounds dissolved in the water. So, what are the dielectric fluid is nothing but a hydrocarbon like kerosene, paraffin, transformer oil, polar organic compounds dissolved in the water. So, the characteristics of the dielectric fluid we will see now. Should have the low viscosity. It should have a low viscosity. So, what is the meaning of a viscosity? Viscosity is the ability of the fluid which resists the free flow. Which resists the free flow of a liquid, that is called as an viscosity. It should have a reasonably safe flash point with maximum available positive ions. What it should have? It should have a reasonably safe flash point with maximum available positive ions. Next, the dielectric circulation system. It consists of a pump, the filter and the connecting pipe. Pump continuously forces the dielectric liquid through the working gap so as to carry out the chips. So, here the pump continuously forces the dielectric liquid. The pump which continuously forces the dielectric liquid through the working gap so as to carry out the chips. That is nothing but it is to carry the excess material that will get in the form of chips while the machining operation takes place. So, filter is used to filter the chips contain dielectric fluid for the reuse. So, here being the filter, as we already know the purpose of the filter, that is used to filter. What purpose filter means? It is used to for the no entry for foreign materials, dust, dirt particles like that. Pump maintains pressure at 0.2 to 0.4 Newton per square mm. Here the dielectric circulation system, the pump which maintains a pressure that is at a range of 0.2 to 0. Newton per square mm. So, pump delivers the dielectric fluid in the form of a jet into the machining zone. Here the purpose of the pump or the work of the pump is to deliver the dielectric fluid in the form of a jet into the machining zone. That is, it will deliver the dielectric fluid in the form of a jet, that means in the form of a high pressure, that is into the machining zone. Tool. The tool should be an electric conductor. Here in the starting we have seen the table that should be made up of an insulating material, whereas here the tool, it should be made up of an electric conductor. Conductor means which from which the electrons get free flow. Determines the metal removal rate and the accuracy. Here it will determines the metal removal rate and the accuracy. Tool is shaped from the cast or drawn solid. The tool is shaped from a cast, that is nothing but a casting, or from the drawing operation. Mostly brass is used as a tooling material. So, here mostly we will use the brass as a tool material. So, others as graphite, copper, phosphorus bronze, tungsten and the tungsten carbide. Condition of that one. The tool should be undersized than the shape of the machine. The major parameter, very good point is the tool should be undersized than the shape of the machine. In EDM process, an oversize of 0.01 to 0.15 mm is produced. Therefore, the tool should be undersized accordingly. So, the tool is made hollow for delivering dielectric to the machining zone. Here the tool should be made up of an hollow. Why it should be made up of an hollow? Means for delivering of an dielectric to the machining zone. Tool wearing is a major disadvantage of EDM. So, in the EDM process, what is the major disadvantage? The wearing of a tool. EDM wire as a tool. See the figure. In the figure, you are seeing clearly EDM, the wire as a tool. EDM elements, power supply. It consists of a AC supply with a rectifier and a spark generator. It consists of a AC supply, that is with a rectifier and the spark generator. Impulse generators are used widely with a adjusting facility. Here we will use the impulse generator, which are used widely with adjusting facility. So, the number of sparks per second can be varied by varying resistance and capacitance provided in the generated circuit. So, here we will see the number of sparks per second can be varied by varying resistance. Here the spark per second, those are varied by the resistance and the capacitance provided in the generated circuit. Power rating varies from 1.5 kilowatts to 10 kilowatts at the voltage rate of 40 to 120 watts. Now, the servo control. The purpose of the servo control is to allow the tool to advance uniformly towards the workpiece during the machining. So, the main function of the servo control is to allows the tool to the advance uniformly towards the workpiece during the machining. So, works are fed hydraulically or electromechanically. Here the works are fed hydraulically or electromechanically. The control feed rates has to maintain a constant gap between the tool and the work. Here the control feed rates, that is the help of an servo control, has to maintain a constant gap between the tool and the work. By this they do not get mesh, they have to maintain the gap. So, prevent unnecessary spark between the tool and the workpiece. So, what will it do? It will prevent the unnecessary spark between the tool and the workpiece. Avoid short circuits. Next, come to the point of a control panel. It is used for the various adjustments like coarse feed adjustment, fine feed adjustment and the impulse period adjustment. These are the three adjustments. What is that? Coarse feed adjustment, fine feed adjustment and the impulse period adjustment. Switches to engage vibratory head or rotary head, to move the tool head upwards, to start the dielectric pump. Here the purpose of the switches is to engage the vibratory head or rotary head, to engage the vibratory head or the rotary head, to move the tool head upwards, to start the dielectric pump. Advantages of EDM. Rapid rate of metal removal, that means at a faster rate we will get a removal of an material. Hard and tough materials can be machined, tungsten carbide ceramics. So, when comparing with the abrasive jet machining, here we can use it to remove the hard and tough materials, that is the tungsten and the carbide ceramics. Complex shapes can be machined for this purpose. Complex shapes means the irregular shapes. Disc electrode or wheel shaped tools is used. Here disc electrode or the wheel shaped tool is used. Absence of mechanical force makes it possible to machine most fragile components. Here there is an absence of an mechanical force. It makes possible to machine most fragile components. Holes of 0.005 mm can be produced in a small delicate parts using a very fine wire as tool. Here the holes of 0.005 mm can be produced in small delicate parts using a very fine wire as a tool. Good surface finish, you will see. Employed in the manufacture of reconditioning of the process tools, forging dies, molds, and used in the injection molding. That is where we will, where is a need of an good accuracy, we will use this process. So, used for thread cutting, micro hole drilling, and the helical profile drilling. For the drilling process also we will use. So, this is the product of an EDM. I think you have seen this figure. This is the output product of an EDM, in which you will see the good accuracy. So, this is also the product of an EDM. Next, the limitations. Electrically non-conducting materials cannot be machined by EDM. Non-conducting materials cannot be machined by the EDM. Non-conducting means through which the which receives the free flow of electrons to positive, that is called as a non-conducting materials. Those cannot be machined by EDM process, that is the electro discharge machining process. It is normally well suitable for small sized components, that is for the small components. Possibility of developing micro cracks on machined surface. So, there is a chances of developing a micro, that means a small or the minor cracks on the machined surface. 12 year limits the degree of accuracy. So, process is slow compared to the conventional methods. So, when comparing with the conventional method, this process is a slow process. So, that is regarding the electro discharge machining, and we will see the video regarding that one, electro discharge machining video. So, now we are going to see the video. This is the video which you are going to see the AJM.
It is also known as abrasive
jet machining,
pencil blasting, and microabrasive blasting. It is an abrasive blasting process that uses abrasives propelled by a high-velocity gas to erode material from the workpiece. What is abrasive? An abrasive is a material, often a mineral, that is used to shape or finish a workpiece through rubbing, which leads to part of the workpiece being worn away by friction. The process makes use of an abrasive jet with high velocity to remove material and provide smooth surface finish to hard metallic workpieces.
So, there is a jet
it is similar to
through which
jet
the
machining
abrasive
process.
particle is getting outside.
To understand
the high
abrasive
speed
machining process fully, watch this video till the end. This video will cover the following
you are
about
seeing the air
abrasive jet
compressor,
machining process. 1.
hopper,
Working principle.
working principle,
2. Construction. 3. Working. 4. Applications. 5. Advantages and disadvantages
of
If you are
AJM.
new to ADTW, click on the subscribe button below and turn on the notification. Let's start. Working principle.
Now, we will see the
The
working
fundamental
principle.
principle of abrasive jet machining involves the use of a high-speed stream of abrasive particles carried by a high-pressure gas or air
With the
on
help
the
of an
workpiece
high
surface
pressure,
through a nozzle.
the abrasive
The metal
particles
is
get,
removed
that is
due
from
to
the
erosion
nozzle.
caused by the abrasive
So,
particles
with the slow
impacting the work
movement, what
surface
will
at high
happen?
speed.
The jet will move.
Construction. The abrasive jet machining setup consists of following things: compressor,
Construction, it consists of a
air
compressor, air filter,
pressure gauge,
flow
flow regulator,
regulator, mixing chamber,
hopper,
hopper,
vibrator,
nozzle,
working.
and the bottom is
The
at the
air is drawn
workpiece.
by the compressor. It
Working.
pressurizes
What
the
will
gas
happen?
to a
The
higher
first the air
pressures.
will
Usually
enter
the
into
air is
the
compressed
hopper.
to a pressures between 25
So,
to
with the help of an
130
air compressor, what will
psi
happen?
G.
It will get
After
compressed.
compressor, there is a filter. The function of
Here
the
you are seeing
filter
the
is to
filter,
clean the impurities
which is used to
present in
clean
the
the impurities
atmospheric
present
air.
in the
After
atmospheric
filter,
air.
there is a pressure gauge, which shows the exact pressure of
Exact
the air
pressure.
coming from the
Which will
compressor.
shows the pressure.
Then the compressed air passes through pressure flow
Regulator valve.
The function of the valve is to regulate the flow rate
Is
of
it used to
abrasive jet.
regulate the flow rate
After
of
this,
an
air passes to
AJM,
the mixing
abrasive
chamber.
particles? In the
It is
bottom you
used
are
to
seeing
mix
the
the
mixing
gas
chamber.
and abrasive
It used to
particles.
mix the gas
Here,
along with
in the
the
mixing
abrasive
chamber,
particles.
the abrasive
In the bottom
particles
you
are
are seeing
fed
the
with the help of
vibrator,
hopper.
and due to the presence
The
of an
usual size of
abrasive
the
and
abrasive
heavy
particles is
gas,
about
what will happen? The abrasive
0.001
particles will
inch
get
or
mixed.
0.025 millimeters.
Uh,
A vibrator is provided below the mixing chamber.
yes.
It controls the abrasive powder feed rate in the mixing chamber. Abrasive powder and the compressed air are thoroughly mixed in the mixing chamber. This pressurized mixture of air and abrasive particles is sent to nozzle. The nozzle increases the velocity
So
of the
the high
mixture
flow
at
is
the
sent into the
expense of its
nozzle.
pressure. In other words, as the pressure drops outside the nozzle, all the pressure energy of the jet is converted into velocity. And this high
So here
velocity
the
jet
pressure
hits the
energy is converted
workpiece.
into the velocity.
This jet is used to remove unwanted materials from the
So
workpiece.
like
This
that
is how
the
abrasive jet
working
machining
operation is
works.
takes place.
Since we understood the working, let us see its applications. The
Applications:
followings are some of the operations that can be performed using abrasive jet machining: drilling,
drilling,
boring,
boring,
milling,
milling,
cleaning,
cleaning,
trimming,
trimming,
surface finishing,
surface finishing,
cutting,
cutting,
bebbering, and
bebbering,
etching.
and etching. So these are the
Advantages:
applications.
1. Smooth
Advantage of
surface
using
finish can be obtained.
smooth surface can be obtained.
2. Hard
Hard
materials and
materials and
materials of
materials
high
of high
strength
strength can
can
be
be
easily
easily machined.
machined.
3. Surface of the
Surface of the workpiece
workpiece is
is
cleaned
cleaned
automatically
automatically
prior to
prior
cutting.
to the cutting.
4. Equipment
Equipment
cost is
cost
low.
is low.
Disadvantages: 1.
Disadvantages:
Abrasive jet machining
AGM
cannot be
cannot be
used
used
for
for the
machining of
machining of
soft
soft
materials.
materials.
2. Nozzle life
Nozzle
is
life is
less.
less,
Nozzle should
should
be
be
maintained
maintained
periodically.
periodically.
3. Metal
Metal
removal
removal rate
rate
is
is
low.
low. 4. In
In
certain
certain
circumstances,
circumstances, abrasive particles
might
might
settle over
settle
the
over the
workpiece.
workpiece.
Hope you have understood abrasive jet machining process. If you like this video and want me to make more such videos, like this video and share with your friends.
So this is a video
Also,
which
if
I
you
have
are new
taken
to
from the
ADTW,
YouTube. The
click
source
on
is
the
an
subscribe
YouTube.
button and turn on the notification so that you never miss an update.
Now we will see regarding the AGM, that is nothing but an abrasive jet machining. For that, the introduction. So abrasive jet machining is a removal of the material from a workpiece by the application of the high speed stream of abrasive particles in a gaseous medium from a nozzle. So abrasive jet machining is a removal of material, that is the removal of excess material from a workpiece by the application of the high speed stream of abrasive particles in the gaseous form, that is through the nozzle. So AGM, abrasive jet machining. AGM is a mechanical method of non-traditional machining. So this is nothing but a non-traditional machining. The material is removed by the mechanical erosion of the work material. Here the material is removed by the mechanical erosion of the work material. See the principle and the equipment of abrasive jet machining. I am making a zoom. So from my right side you are seeing the pressure gauge, filter gas supply, regulator, vibrating power supply, mixing chamber, connecting hose, the bottom nozzle, abrasive jet and the workpiece. This is the figure, and the components, the major components is a mixing chamber fitted with the pressure gauge, gas supplier, connecting nozzle, the connecting nose or the hose and the nozzle. See the AJM process. So the air and the particle stream is entering into the nozzle. What is happening here? The air and the particles of the stream, these both are entering into the nozzle. The tip made up of a tungsten carbide of the gem. The tip, that is nothing but a nozzle tip which is made up of a tungsten carbide of gem. So there should be we should maintain the gap between the nozzle and the workpiece, approximately that is n 0.8 mm. In the figure you are seeing that clearly, and the velocity 150 to 300 meters per second, and the gap, the nozzle gap is the 0.3 to 0.5 mm. So in the figure you are seeing clearly the air and the particle stream, that is something but the air and the abrasive particles, those are ejecting from the nozzle to the workpiece with a high velocity, that is 150 to 300 meters per second. So, due to the continuous flow and the continuous flow of the particles, what will happen? There is an mechanical erosion process. The filtered gas under pressure is supplied to the mixing chamber. The filtered gas under the pressure is supplied to the mixing chamber. Mixing chamber contains a abrasive powder and vibrated at 50 C by second. Mixing chamber contains the abrasive powder and the vibrates. Entrains the abrasive particles and are then passed to the connecting hose. The abrasive particles and the gas mixture emerges from the nozzle with a high velocity. The nozzle tip, which is made up of a tungsten carbide, as we have seen the earlier, the abrasive and the gas mixture emerges from a nozzle at a very high velocity. The amplitude of vibration of the mixing chamber controls the feed rate of abrasive powder. The amplitude of vibration of the mixing chamber controls the feed rate of abrasive powder. The pressure regulator controls the gas flow and the pressure. Pressure regulator controls the gas flow and the pressure. The nozzle is mounted on a fixture, that is the nozzle is placed on the fixture. Either the workpiece or nozzle is moved by the cam, pantographs or other suitable mechanism so as to control the size and the shape of the cut. Either the workpiece or the nozzle is moved by the cam or the pantographs or other suitable mechanism so as to control the size and the shape of the cut. A dust removal equipment is necessary to protect the environment, that is nothing but a filter. A dust removal equipment is nothing but a filter that is necessary to protect the environment. AGM elements and their influence. Metal removal rate, geometry of cut, surface roughness and the nozzle wear rate are influenced by the following elements. We will see those elements. Nozzle, it is dependent upon the geometry, composition, distance from the workpiece and the inclination of the work. Surface. Abrasives, composition, strength, size, shape and the flow rate. Carrier gas, composition, pressure and the velocity. So, AGM elements. Nozzle. Nozzle directs the abrasive particles at a very high velocity into the workpiece. What will happen here? The nozzle directs the abrasive particles at very high velocity into the workpiece. The material of the nozzle is subjected to the abrasion wear and hence are of hard material such as tungsten carbide and synthetic sapphire. The material of the nozzle is subjected to the abrasion wear and hence are of hard material such as tungsten carbide or synthetic sapphire. So, this is the figure of the ASAM nozzle. Sapphire orifice, abrasive particles and the mixing tube. From the top you are seeing the high pressure water. Inlet water, abrasive, mixing tube, jewel and the guard. Nozzle. Tungsten nozzles have an average life of 8 to 12 hours. So, the tungsten nozzle have a life of 8 to 12 hours. Sapphire nozzle lasts for about 300 hours of operation when used with 27 mm abrasive power. So, sapphire nozzles last for about 300 hours of operation when used with the 27 mm abrasive powder. The distance of the nozzle from the workpiece influences the rate of metal removed and the size of machined area. So, the amount of material rate that is depend upon the distance of the nozzle. Abrasive particles from the nozzle flow a parallel path for a short distance and then the jet flares resulting over the size of the nozzle. The abrasive particles from the nozzle flow a parallel path for a short distance, and then the jet flares resulting over the size of the nozzle. The jet stream is initially cylindrical for a distance of about 1.6 mm, and then it flares into a cone 7 degrees Celsius included angle. AJM elements, abrasive material, aluminum oxide, silicon carbide, glass powder, or specially prepared sodium carbonate. So, what are the abrasive materials? Those are nothing but an aluminum oxide, silicon carbide, glass powder, or specially prepared sodium carbonate. The abrasive particle size is a dominant factor in the AJM. Dominant factor. What is the dominant factor in the abrasive AJM process? Means the abrasive particle size. Abrasives cannot be reused because of the reduced cutting action. So, the abrasive particles, they cannot be reused, that is due to the reduced cutting action. Abrasive flow rate influences the metal removal rate. Abrasive flow rate influences the metal removal rate. The maximum metal removal rate depends on the flow rate of abrasives. The maximum metal remove depend upon the flow rate of an abrasives. So, in the figure you are seeing the AJM process. I am making it a zoom such that you can see clearly. Now, the carrier gas, air, nitrogen or carbon dioxide is used as a carrier gas. So, in this AGM process, the air, nitrogen or the carbon dioxide is used as a carrier gas. Air must be filtered to remove the water. The air must be filtered, that is to remove the water, oil and the other contaminants. So, the pressure required in the region is about 2 to 8 kgs per centimeter square. The velocity of the abrasive stream is about 300 meters per second when it emerges the nozzle. So, in this process the velocity of the abrasive stream is about 300 meters per second when it is emerges, that is when it is get out from the nozzle. The summary of the parameters of abrasive jet machine: medium air and CO2, abrasive Al2O3 or SiC, non-recirculating and size 20 to 50 mm, flow rate of abrasive 3 to 20 gas per minute, velocity 150 to 300 meters per minute, pressure 2 to 8 kgs per centimeter square, nozzle size 0.07 to 0.40 mm, material of the nozzle sapphire, tungsten and the carbide. So, the same we will see here. Next, the advantages: ability to cut the intricate or the irregular shapes in a material of any hardness and the brittleness. So, the main speciality of the abrasive jet machining is to cut irregular shapes in material of any hardness or brittleness. Ability to cut fragile and heat sensitive materials without the damage. Low capital cost. Disadvantages: metal removal rate is slow and hence its application is limited. So, in this process the metal removal rate is slow and hence its applications is limited. Stray cutting can occur and hence accuracy is not good. Stray cutting can occur and hence accuracy is not good. Embedding of the abrasive in the workpiece surface may occur while machining softer materials. Embedding of the abrasive in the workpiece surface may occur while machining softer materials. Brittle and heat sensitive materials like glass, quartz, sapphire, semiconductor material, mica, and ceramics can be machined. So, the brittle and the heat sensitive materials like the gas, quartz, sapphire, semiconductor material, mica, and the ceramics, these are can be machined. So, drilling holes and the cutting slots, cleaning hard surfaces, cutting fine lines, deburring, scribing, grooving, and splashing. So, these are the different works which you can do with the help of an AJ. Delicate cleaning such as removal of a smudges. Delicate cleaning is nothing but such as removal of an smudges from the antique document used for cleaning and polishing of a plastics, nylon, and the Teflon components. So, that is regarding the abrasive jet machining process. Now, we will see the video which I have downloaded from the YouTube. Now, we will see such that you can clearly understand the process.
Laser beam machining. And laser beam machining is a non-conventional machining process in which a laser is produced when the electrons in atoms of special crystals are energized using electric current. Generally, garnet crystals are most commonly used in solid-state lasers. Yttrium, aluminium garnets, and doped with neodymium, which is also called NdYAG, are most popularly used. These excited electrons emit photons. Photons are the particles of light, and these emitted photons form a concentrated beam of light, forming a laser. Laser beam machining is best suited for machining brittle materials with low conductivity, but can be used on almost every material. To understand the laser beam machining process, watch this video till the end. This video will cover the following about the laser beam machining process. 1. Working principle. 2. Construction. 3. Working. 4. Parameter affecting the machining process. 5. Applications. 6. Advantages and disadvantages. Working principle. In this machining process, as the laser beam strikes the surface of the workpiece, the heat energy from the laser beam is transferred to the workpiece. This heat energy absorbed, melts and vaporizes the material from the workpiece surface. Construction. The laser beam machine consists of following parts. Power supply. It requires the power supply of 1 to 10 kilowatt. A high voltage power source is used to produce light in flashlight tubes. Flash lamp. Flash lamp or flash tube is used to charge the electrons of the atoms in the crystal, which is also called as pumping medium. Capacitor. Capacitor is used for operating the laser beam machine in pulses. Pumping medium. Pumping medium, in this case, is a ruby crystal, which has a large number of atoms, which when absorbs the energy, their electrons produce photons. Working. When the switch is turned on, a high voltage power supply is applied across the flashlight or flash tube surrounding the pumping medium, in our case it's ruby crystal. As the light is powered on, it emits high energy photons. These photons are absorbed by the ruby crystal. This absorbed energy causes most of the electrons contained in the atoms of the ruby crystals to be excited at a high energy level from its ground state. After a short duration, as the electrons from high energy level comes to ground state, they emit photons. This emitted photon stimulates the excited electrons to return to their ground state, thus producing more photons as they return to their ground state. Thus a pair of photons are obtained by utilizing one photon. Thus, we call this process as amplification of light using stimulated radiation. As the photon's concentration increases, the laser is formed. A 100% reflective mirror is used to reflect all the photons back to the crystal, whereas a semi-reflective mirror reflects some of the
లేదు వాళ్ళ
photons
ఇంటికి
back,
వెళ్ళి
and escaping
క్లాస్ చెప్తాను
photons
ఎప్పుడు
through a semi-reflective mirror forms a high-energy
క్లాస్ చెప్తానా
laser beam. Then a lens
క్లాస్
is
చెప్తాను
used to
భయ్
focus the
ఏ
laser
ఇప్పుడు
beam
కష్టం
onto the workpiece to be
క్లాస్
machined.
క్లాస్లో ఉన్నాయి ఇప్పుడు కష్టం.
Interaction of laser and workpiece produce a large amount of heat, thus vaporizing the surface of the workpiece, thus cutting grooves of various shapes, or cutting the workpiece. Application of laser beam machining process. Engraving,
దేవుడి దయ కానీ మా సార్ ఆడ
welding,
క్లాస్ చెప్తాడు. ఇప్పుడు వద్దా,
surface
నేను
treatment,
మళ్ళీ ఇస్తావు, నిజంగా ఇస్తా.
cutting, drilling.
కాసేపు ఆవు.
It is also
అటెండెన్స్
used in
తీసుకుంటే ఇప్పుడు
shipbuilding,
అటెండెన్స్
automobile,
తీసుకుంటే ఇప్పుడు కాసేపు
aerospace,
ఆవు.
steel, electrical, and
ఇస్తా
medical
ఇస్తలే.
industries for precise machining of the various parts. Advantages of laser beam machining. 1. There are no direct contact between the tool and workpiece. 2. It can machine both conductive as well as non-conductive material. 3. It can be focused to very small diameter, thus extremely small diameter holes can be machined in the workpiece, and higher machining accuracy are possible. 4. There is no tool wear as in conventional machining process. 5. Complex shapes of different sizes can be machined, as the laser can be moved in any path. 6. It gives very good surface finish. Disadvantages of laser beam machining. 1. It requires lot of energy for machining process. Very low rate of material removal. 3. The lifespan of the lamp is short. Hope you have understood laser beam machining process. If you are new to ADTW, consider subscribing this channel. And if you want to see more videos like this in the future, support our work by sharing these video with your friends. If you like this video, let us know by clicking on the like button. Also you can comment your opinion. Abrasive Jet Machining Process, AJM. It is also known as abrasive micro-blasting, pencil blasting, and micro-abrasive blasting. It is an abrasive blasting process that uses abrasives propelled by a high-velocity gas to erode material from the workpiece. What is abrasive? An abrasive is a material, often a mineral, that is used to shape or finish a workpiece through rubbing, which leads to part of the workpiece being worn away by friction. The process makes use of an abrasive jet with high velocity to remove material and provide smooth surface finish to hard metallic workpieces. It is similar to water jet machining process. To understand abrasive machining process fully, watch this video till the end. This video will cover the following about abrasive jet machining process. 1. Working principle. 2. Construction. 3. Working. 4. Applications. 5. Advantages and disadvantages. If you are new to ADTW, click on the subscribe button below and turn on the notification. Let's start. Working principle. The fundamental principle of abrasive jet machining involves the use of a high-speed stream of abrasive particles carried by a high-pressure gas or air on the workpiece surface through a nozzle. The metal is removed due to erosion caused by the abrasive particles impacting the work surface at high speed. Construction. The abrasive jet machining setup consists of following things: compressor, air filter, pressure gauge, flow regulator, mixing chamber, hopper, vibrator, nozzle. Working. The air is drawn by the compressor, it pressurizes the gas to a higher pressures. Usually the air is compressed to a pressures between 25 to 130 psi/g. After compressor, there is a filter. The function of the filter is to clean the impurities present in the atmospheric air. After filter, there is a pressure gauge, which shows the exact pressure of the air coming from the compressor. Then the compressed air passes through pressure flow regulator valve. The function of the valve is to regulate the flow rate of abrasive jet. After this, air passes to the mixing chamber. It is used to mix the gas and abrasive particles. Here, in the mixing chamber, the abrasive particles are fed with the help of hopper. The usual size of the abrasive particles is about 0.001 inch or 0.025 millimeters. A vibrator is provided below the mixing chamber. It controls the abrasive powder feed rate in the mixing chamber. Abrasive powder and the compressed air are thoroughly mixed in the mixing chamber. This pressurized mixture of air and abrasive particles is sent to nozzle. The nozzle increases the velocity of the mixture at the expense of its pressure. In other words, as the pressure drops outside the nozzle, all the pressure energy of the jet is converted into velocity. And this high velocity jet hits the workpiece. This jet is used to remove unwanted materials from the workpiece. This is how abrasive jet machining works. Since we understood the working, let us see its applications. The followings are some of the operations that can be performed using abrasive jet machining: drilling, boring, milling, cleaning, trimming, surface finishing, cutting, bebbering, and etching. Advantages: 1. Smooth surface finish can be obtained. 2. Hard materials and materials of high strength can be easily machined. 3. Surface of the workpiece is cleaned automatically prior to cutting. 4. Equipment cost is low. Disadvantages: 1. Abrasive jet machining cannot be used for machining of soft materials. 2. Nozzle life is less. Nozzle should be maintained periodically. 3. Metal removal rate is low. 4. In certain circumstances, abrasive particles might settle over the workpiece. Hope you have understood abrasive jet machining process. If you like this video and want me to make more such videos, like this video and share with your friends. Also, if you are new to ADTW, click on the subscribe button and turn on the notification so that you never miss an update.
Today we will discuss about the abrasive jet machining, in which we will use abrasives for metal removal process. Firstly, we will discuss about the parts of the abrasive jet machining. We have a gas cylinder in which we can use dry air, nitrogen or carbon dioxide, anyone be used in this cylinder for the abrasive jet machining or for metal removal purpose. Then we have a filter which will filter the air or gas. Then we have a pressure gauge, a mixing chamber where gas, air or powder of the abrasive will be mixed, which is connected to the vibrator. Vibrator will efficiently mix all the powder foam and gas with together, and a control valve which will control the supply of the gas with abrasive. Then we have a nozzle for increasing the kinetic energy of the mixing of powder and air or gas. These all are connected with the help of pipes. Then we have a workpiece and a fixture on which workpiece is fixed. Then what will happen? This is a powder supply duct from where powder will be supplied to the mixing chamber. Now what will happen? Gas will come through this cylinder and reach in the mixing chamber. From there, powder of the abrasive will be supplied from this duct and it will reach in the mixing chamber. And in the mixing chamber, vibrator will start vibrating and it will mix air and powder of abrasive with efficient manner. Then this mixing of the powder and air or gas will reach to the nozzle, and where nozzle will throw this mixing of powder and gas on the workpiece and will remove the metal from the workpiece. From this process, abrasive and mixing air or gas will work together for removal of metal from the workpiece. So this is the working of abrasive jet machining. Thank you for seeing this video. For more videos, you can subscribe me on my channel Learn and Grow. Thank you.
Today we will discuss electric discharge machining, EDM. So EDM, the removal of the material is based upon the electric discharge erosion, that is generally known as EDE effect of electric spark, that is occurring between two electrodes that are separated by a dielectric liquid. So here we have a tank. In this tank, dielectric fluid is filled, and the main function of the dielectric fluid are it flushes the eroded particles from the machining gap, and it provides the insulation between the electrode and the workpiece, and cool the section that was heated by the discharging effect. And the main requirement of EDM dielectric fluids are it has adequate viscosity, low cost, good electric discharge efficiency, high flash point, good oxidation stability, minimum odor. So for most EDM operations, kerosene is used with certain additives that prevent gas bubbles and deodoring. This is a fixture and on which workpiece anode is mounted. This is a pipeline goes towards the pump, and this is a filter that is generally used to remove the debris that are remain in the fluid and supply the filtered dielectric fluid to the tank and through the electrode. And this is a flushing nozzle. This is the graphite or copper electrode and normally negative charged and cathode. Metal with high melting point and good electric conductivity are usually chosen as tool material for EDM. So generally graphite is most common electrode material. Since it has fair wear characteristics and is easily machinable, and small flush hole can be drilled into graphite electrode. And copper has good EDM wear and better conductivity. And copper graphite is good for high machining rate as well as low electrode wear. And it has better electrical conductivity than graphite, while the corner wear is higher. So these are some specifications for choosing the electrode for EDM. So from here the electric is supplied through the electrode from the filter, and this is a feed, generally tool feed servo control unit. It is feed is provided from the servo control unit, which maintains a constant machining gap that ensures the occurrence of the active discharge between two electrodes. And this is the DC plus pulse generator. The power supply is